Now let us look at a function for counting the number of nodes in a linked list. That is, knowing the length of a linked list. If I count the nodes, 1, 2, 3, 4, 5 nodes I have. So for this, we have to traverse through the linked list until we reach that last node, and every time we should go on counting. So with this way, we can know the number of nodes in a linked list. So I'll show you the working. I should have some variable, let us say count, and that count is initially 0. Then I should have a pointer p pointing on this first node whose address is 200. So this p will be 200. First step, increment count. So add 1 to it and move p to the next node. Then again do the same thing. Add 1 to count and move p to next node. Add 1 to count and move p to next node. Same way, add 1 to count, move p to next node. Add 1 to count and move p to next node. So this next node is 0, so it is null. So when p became null, stop that. So this is how the procedure is, and it is very simple. So we have to traverse through the linked list and go on incrementing count. So for this, I will write on a function. Let us make it as a function integer count, which takes parameter, that is struct node pointer p. Then for counting, I need some variable, let us say c, which is having value 0. Then in this c variable, I'll be incrementing, I'll be counting it. So every time say c++ counting for incrementing this value and move p to next node, p assign, p is next. And this procedure, I have to go on repeating it. So this should be written in a while loop. So while, what should be the condition? I should stop when p becomes null. So I should continue when p is not equal to null. So p is not equal to 0. So null can also be written as 0. Then at the end of loop, we will have the number of nodes in variable c. So return c. That's all. Now let us analyze the time taken by this function. See, this function is traversing through all the nodes and simply counting. So if I remove this line, then this is same as a traversing, which we have seen in the previous video. So how much time it takes for traversing all the nodes in a linked list? It depends on number of nodes. So if n nodes are there, then we say time is order of n. Time taken is order of n. So mostly the functions that are written upon linked lists, they will be taking order of n time. So we may not be analyzing it every time. So I'll just mention the time. So it's order of n. Then what about the space taken by this function? The space complexity depends on the number of variables or data members it is having. Like this is one pointer and an integer. That's all. Only two things are there. So pointer takes, let us say, 2 bytes. So an integer also takes 2 bytes. Assume this. Total 4 bytes of memory is taking. So 4 bytes means 4 is constant. Time is n and space is constant. So we have finished the iterative version of count. Now let us write a recursive function for counting. So I will write the recursive function, then I will explain how it works. I will write the recursive function. Function name, I am taking it as count only. Then it is taking a pointer. So we will be calling it by passing first node's pointer, that is 200. What it should do, if p is not null, it should count 1 for each node. And if it is null, then it should count 0. So I will write on the condition. If p is equals to null, then return 0. So if there is no node, then return 0. Otherwise, if there is a node, then return count itself for p is next and also add 1. That's all. This is the function. Simple steps are defined. If p is null, then return 0. There is no node. If there is a node, then call for next node and add 1. So let us quickly trace this one and see how it is working. When we call this function for first node, that is 200, I'm writing C for count. Then what it does, this is not null, so it will always go into the else part. It is not null, so it goes into the else part. So for almost all the nodes, it will be in else part only. So I will simply write down the steps one by one. So call itself for the next node, that is 210, and add 1. When to add 1? Not now, because unless this answer is known, we cannot add 1 to it. So 1 will not be added right now. The next call, C for next node, that is 270 and plus 1. This will be done afterwards. The next call, C for 300 and add 1. Adding 1 will be done afterwards. C of 350 and add 1. Adding 1 will be done afterwards. So for 350, C of 0 plus 1, adding 1 will be done afterwards. So you can see that in all these steps, it has entered into the else part only. Now P became null. So P is null. So when P is null, what it returns? It returns a 0. So this time this is 0. So the result of this function is 0. So this will be 0 plus 1 is 1. And the result of this function is 1. So this will be 1 plus 1, that is 2. So the result of this function is 2. So this is 2 plus 1 is 3. So result of this function is 3. See, when this function is called, so whatever the result that we get, return value will be the value of that function only. So this is 3. So this is 3 plus 1. So it will be 4. So the result of this function is 4. So 4 plus 1 is 5. So the result of this function is 5. So this is how it works. So we can observe that addition is being done at returning time. It is not done at calling time. Now I'll make one small change and show you. See, sometimes students believe that if I write return 1 plus count, instead of writing plus 1 afterwards, if I add first, then will it add while calling? No. See this one. For this also, C of 200, 1 plus with what? This function call, C of 210. So 1 will be added with the result of 210. So unless the result of 210 is known, addition cannot be done. So still this addition has to be done at returning time only. So I have done the tracing. Now if you see the time taken by this function is 1, 2, 3, 4, 5, 6 calls. So n plus 1 calls, so it is order of n. And the space, definitely it uses a stack because it is recursion. We have already seen in previous video how the stack is constructed. So the space complexity is n plus 1, that is order of n. So the time and space for this function is order of n only. So this function is costly in terms of space. In terms of time, it is same as the iterative function, that is using loop we have written the function, it is same as that, but in terms of space it is costly. Now I will make some changes in this function and show you what are the other ways I can write down same function. Let us see what are the changes we can do in the code, and the results remain same only. See, inside if, when we have return statement, then if this is true it will return, so it will not go further. So no need of else. Without else also you can write it. Instead of writing this termination condition, I can write it in other way, like if P is not equal to null, that is not equal to 0, then return 1 plus count P caps next, else return 0. See, here I have written this condition first, so I was returning 0, otherwise this was there. But now I have just changed the order. If P is not null, then do this, otherwise do this. So you can write, you can change the order also. Now one more thing I'll show you. I'll write the function using some variable. I will declare some variable, local variable x, having value 0. If P means P is not null. You remember in one of the video I have shown you this one. This will be true if P is pointing on some node. If P is null, then it will be false. So this is for P pointing on some node, that is not null. If it is not null, then x assign call count with next node. So we'll call this function and get the result in x. Then we will return x plus 1. So I have introduced one variable. See, earlier in the previous one, this was count, p is next, then plus 1. So instead of writing count here, I have taken it in some variable, then that variable I am using here. So you can introduce a variable also. Next. Then else, if it is null, then return 0. So I will return 0. So see, if it is coming in else part means x is remaining 0 only. So even I can say return x. This means 0 only. So you can introduce a variable also.